So today we are going to show you how to use the debugger that is available in every Windows box. And we use the command prompt window, and it's command line driven, meaning that you type instead of using a mouse. And the debugger is called Debug. So when you get debug, the all the commands have to be typed in, so we have to use the question mark, and that will give us a listing of all the commands available. The ones that we are going to use today are register to display the contents of our CPU registers. We are going to use dump or D to display the contents of our data segment. We are going to use E for enter to fill the contents or change the contents of our data segment. And towards the end, we're going to be using the assemble command to enter in code into our code segment, and then finally the trace command to execute the code one at a time. So let's start off with the register command. R, enter. And this will display the complete listing of the CPU registers. Remember from our lecture, we've got the AX register, the BX register, CX, and DX. Following, we have the special indexing registers of SI and DI and BP. We will be discussing the stack pointer in a later tutorial. And then finally over here we've got the codes, the segment registers. We have data, extra segment, stack segment, and code segment. IP is our instruction pointer where we will execute code, and over here these are our flags. Okay, where we'll do exercises on those in a later date, but that's just to introduce you to it. So now if I type the register command again, but put the name of register, that allows us to change the contents. We get a little semicolon over here, and I'll go 1, 2, 3, 4. And if I hit enter, R again to display the contents, you see now that the register AX is now equal to 1, 2, 3, 4. If we now go register AX and we go A, B, C, D, why this is different is this is the hexadecimal. Remember, everything we do in the debugger is hexadecimal. We are not using decimal at all. So register contents of AX is now equal to A, B, C, D in hexadecimal. Okay, those are the registers. Let's do the data. So for the data, it's the dump command. So we're going to dump the contents of the data segment at offset 0. I'm picking 0. We could pick 100. We'll do that later. Okay, so to understand this part of the display, this is the contents of our data segment. Do you see it up there? Where's our data segment? It's OBC, well, OB3C. So OB3C, offset 0. Now following that are 16 entries, okay, and the corresponding to the 16 bytes starting at offset 0. So this is CD is at offset 0, 20 is at offset 1, FF is offset 2, 3, 4, 5, 6, 7. The hyphen here is just a visual aid for you to help, because this is the first 8 bytes from 0 to 7, and this is another 8 bytes from 8 to 15, or in hexadecimal F. Okay, so that means we have 16 bytes in the first row, and that means the next row corresponds to offset 10, where 10 hex, which is 1 times 16. Okay, so we've got another 32. Oh, another 16. So the 2 rows is 32, and that's why we have the next offset at address offset 20 hex, which is 32 in decimal. So this is the address offsets, this is the contents of the bytes, and then finally on the right hand side is we've got the debugger's attempt to convert the bytes into ASCII codes. Whenever you see a period, it means that the byte over here doesn't correspond to a printable ASCII character. So we see over here CD is dot, so that means it's not a printable character. Whereas 4F here, corresponds to the letter O over here. 3 over here is equal to 33 hex. Okay? So we've displayed the contents. Let's try and change the contents. So we use the enter command. We go to the data segment at address offset 0. And instead of CD, let's put in 41. Spacebar, 42. Spacebar, 43. Spacebar, 20. Spacebar, last one, 31. If I hit enter now, we leave this command and we can now redisplay the contents of our data segment, ds:0. Compared to before, we see the contents have changed where we've changed it. So at offset 1, it's now 41. 41, if you remember our little lecture, corresponds to capital A over here. 42 corresponds to capital B. 43, capital C. 20 is our space. And 31 is a number 1. Those are the changes that we have made to the data segment. Okay. Our next little task in this is to review Little Indian when we're looking at memory. To do this, we're actually going to execute something, okay? And so that means I'm going to have to put some code into the machine. So I'm going to assemble an instruction, and because an instruction is code, we're not going to go to the data segment, we're going to go to the code segment. So we're going to go to the code segment, and I'm going to use the address 100, because way up here, if we look at the contents of the instruction and pointer, the next instruction to be fetched is at address 100 hex. So I'm going to put in 100. So at code segment offset 100, I'm going to put in the instruction move square bracket 0, comma AX. Now, I know we haven't covered this yet. If I hit enter, it leaves this mode, right? And goes back to the command line. We haven't covered this yet, but let me explain. This is going to take the current contents of AX, which is what? Way up here, it's A, B, C, D. And it's going to put it at the location 0 in the data segment. Okay? And location 0 in the data segment is 41. Now, because AX is a word, it's 16 bytes wide, it's actually going to write it to byte 0 and byte 1. So we're going to see A, B, C, D going in and clobbering this content. So to do that, I have to execute this code. To execute one instruction, you enter T, and it will go to the code segment, the current IP, and execute this line of code. So I hit T, and it's executed it. After it's executed, it redisplays the current contents of the registers. AX is still the same because we're moving from AX into data segment. So the only register that's changed is really the IP, and the IP has changed because we have fetched and executed this one, and that means the next instruction is there. So just as a little mental exercise, it took 3 bytes to encode this instruction, but that we're getting ahead of ourselves there. So let's look at what happened to our data segment, because we were supposed to move A, B, C, D into this address. So let's dump data segment :0. And you see there's, it's not A, B, C, D, it's C, D, A, B. And this is what I mean about Little Indian. Okay? This is the most significant byte of AX, so it goes into the higher address 1. This is the least significant address, byte of AX, so it goes into the lower address of 0. Okay, so that's going in that direction. So let's go in and what's our final little pause here? I'm going to pause. So let's do 2 more little exercises in this. One is we're going to do the same thing but go the other way. So I'm going to assemble and I'm going to go to CS:100. Okay, so I'm going to overwrite it. And now this time what I'm going to do is I'm going to move AX, comma, 0. What's the difference? Previously, AX is in the source and the address offset 0 is in the destination. Now we're going to get the contents of address 0 and put it into AX. Now to actually run this, we have to prepare a little bit. Whoops. There we go. First of all, let's check our registers. Our IP is 103. If I execute T and my instruction's at 100, it's not going to work. It's going to go to 103 and execute whatever's there, and nothing's there. So we're going to go register IP, and we're going to stick it back to 0. That's the great thing about a debugger, is that you can change the contents of even the instruction that you're going to fetch. So now our IP is pointing to 100, our code is at 100, and now we're going to execute that instruction. Our current contents is a C, D, A, B, and our register is A, B, C, D. Now to make this more interesting, let's change the contents of our data segment. Enter data segment : 0. And I'm going to put in 41, 42. Let's do a dump of our data segment. And it's 41, 42. So we're going to move 41, 42 into AX. Can you predict what's going to be the contents of AX after this? Get your prediction ready because I'm going to execute it. T, and it's 4.